So what we are going to discuss now is the continuation of the video lesson I shared last time. This is last time we talked about Polias model for problem solving, the four-step process. Okay, so today we are going to look onto the different strategies in problem solving. No? So these strategies is mentioned in devising a plan, and we will try to give examples for each strategy that we have mentioned in that part of Polias model, no? That devising the plan. Okay, so by the end of this lesson, uh, it is expected for you to apply these strategies mentioned in this PowerPoint presentation. Okay, so I will just start with the first strategy, the working backwards. No? Working backwards. So working backwards is like um, when you try to, it's like solving a maze puzzle. No? Working backwards is like solving a maze puzzle. So instead of doing from the starting point then to end point, what you usually do is we try to connect the path, the maze. We start from the finish line. Then we'll try to find a way from the finish line. We'll try to find a way where it is connected from the starting point. No, from there, then we will just go through that. We will just draw or something link the path that would connect from the starting point to the finish line. You know? So yun, that's working backwards, no? So we will start at the end point, no? So for let us try to apply this strategy using this problem in this problem. Okay. So when a number is multiplied by 15, then the result is added by 15 also. The answer is 240. What do you think is the number? So what you usually do is you try to apply algebra, no? Then from algebra, then you solve the missing the number, no? Or you look for n or x. Okay, in the working backward strategy, we'll try to invert the operation. Okay, we will start with the answer 240. Now, since the last operation is added by 15, so if we do it inversely, so we will get 200, instead of adding, we will do minus. So we will have 240 minus 15, and we will get 225. Okay. Then let's go back to the previous one. When a number is multiplied by 15, so in the forward direction, it's multiplied by 15. So if we do it backwards, then we will do divide. Okay. So we have 225 divided by 15, and the answer is 15. So we could say that the number is 15, or 15 is the number. Now let us try to check now if our answer is correct. We'll try to check. 15 times 15. What is the answer?
225, sir.
225. Okay, 225 plus 15.
240, sir.
240.
240. So do we have the same answer here? 240.
Yes, sir.
So therefore, we could say our answer is correct. No? So we could say our answer here is correct. So that's how working backwards works. No? So we will start from the end, then we will do then backwards. No? We will start at the end point, then do the solve the problem backwards. Okay. Next strategy is looking a pattern. Okay, so looking a pattern. So if you try to look for maybe for finding a pattern or looking a pattern, maybe you try to look for some recurring observations, or if not with the recurring observations, maybe um, a common multiplier, no, or maybe you can have a common difference, no. So you add it with a particular number, or you add with uh, um, or you um, multiply it with a particular number, and so on. No? So um, many there are many possible ways, no, that a pattern would occur. It could be a sequence, or it could be a series, or it could just be a recurring observation. Okay, so let us try to solve this given problem using a pattern. So what is the ones digit of 3 to the power of 100? So for this one, okay, so we know that 3 to the power of 1 is 3, no? And the ones digit there is 3. Ones digit is the last digit of the number. Okay, so 3 to the power of 2, we have 9. And the ones digit here is 9. And if we have 3 to the power of 3, we have 27. And the ones digit here is 7. And if we have 3 to the power of 4, we have 81. The ones digit is 1. Then if you have 3 to the power of 5, we have 243. The ones digit here is 3. If you have 3 to the power of 6, we have 729. The ones digit here is 9. Okay, so if we raise it to the power of 7, 3 to the power of 7, we have the answer here is 2, 1. What is this? 2187. Is it 2187? No, 2187. Okay, so the ones digit there is 7. No? So if we try to look at the pattern, okay, the last digit of the powers of 3 will be like this: 3, 9, 7, 1, 3, 9, 7, 1, 3, 9, 7, 1. And the pattern keeps on repeating by every powers of 4. No? So by every powers of 4, it will go back to 3. So 3, 9, 7, 1. So after uh, the powers of 4, it will go back to 3, 3, 9, 7, 1, and so on. Okay, since 100, no, since 100 is a multiple of 4, okay, so since 100 is a multiple of 4 or divisible by 4, so therefore we can say here that the ones digit for 3 to the power of 100 is 1. Okay. Okay, this kind of problem, class on the wiki, you cannot solve this using calculator, since the calculator will just give you a scientific notation, the exact number, no, because the digit is very long. But based on the patterns that we have, we can assure that the ones digit of this number, 3 to the power of 100, is really 1. No? Okay, so that's how we use looking at pattern here. Okay. So in this case, we have a recurring observation, no? 3971, 3971, and so on. There are some patterns like series or sequence, and maybe we will have a separate topic for that one. Maybe we'll talk about that one 2 meetings or 3 meetings from now. No? So we will talk about patterns later. Okay, the next strategy is adopting a different point of view. Okay. Adopting different point of view, it's like from uh, if you try to recall in the Polius model, now in the last part, looking back, there is a question there. Can you solve this problem in another way? You know? So adopting different point of view, it's like that one. So you try to solve the given problem in another method or in a simple way of uh, finding the answer of the problem. No? So that's adopting a different point of view. Okay, let's try to solve this problem uh, using this strategy. Okay. Okay. The most common method that you are going to apply for this problem is that you are going to apply the trial and error here. No? So you try to, let's say you try to assign A with 1, B with 2, and so on. No? And you will get some answers. No? And if we try to do that one, it might take us time to solve for it. So what we can observe here, this expression here, no? So we can factor them out, right? No, so we can factor them out. So instead of applying directly the guess and check method or the trial and error, why not we will try to factor this first, then later on we will just apply the trial and error or the guess and check. So okay, so I can factor this one into A plus C and B plus D, and from there I can efficiently do now my guess and check, my trial and error. You know, so through guess and check solution, this would lead to this answer, and the highest and largest number, possible number, combination of numbers that we can do, and the greatest value is equal to 25. Okay, so that's how we do it. No? So instead of doing the trial and error immediately, we try to factor it first. Then after we factor it, then that's the time we do the trial and error method or the guess and check method. So for here, 25 is the greatest value. Next one is solving a simple analogous problem. No? Um, when you say solving a simple analogous problem, it's like you have a given problem, a bigger problem. You try to break down that kind of problem, and you try to solve it by its smaller parts. No? And from that smaller parts, we will try to generalize. So that's how solving simple analogous problem works. Okay. So let us try to apply this um, strategy in solving this given problem. No? What is the difference when the sum of first 100 odd numbers is subtracted from the first 100 even numbers? Okay, most of you would think or would answer this in this manner, no? So you try to solve it the first 100, the sum of the first 100 odd numbers, and the first sum of the first 100 even numbers, no? And from there, you try to subtract. Now from there, you try to subtract. Okay, but there is a much simpler way of solving this problem, no? Other than uh, the thing that I mentioned earlier. Instead of doing that way, why not we try to subtract them first, no? Subtract the first odd and first even, second odd and second even, third odd and third even, and so on. No? So we try to it by its parts, by elements, ano? So first odd, first even, second odd, second even, third odd, third even. So we can do 2 minus 1, 4 minus 3, plus 6 minus 5, and so on. No? So we can try it using this way. And we know 2 minus 1 is 1, right? And 4 minus 3 is 1. 6 minus 5 is 1. And there are 100 ones. So therefore, 1 times 100, the answer here is 100. So that's how solving simple analogous problem works. So instead of solving it as a whole, why not we solve it by parts? Then by parts, we try to generalize. So that's how solving analogous problem works. Okay, next strategy is considering extreme cases. No? Considering extreme cases. Considering extreme cases, it's like this. You try to consider either the smallest as possible quantity or the largest possible quantity. No? It could be the largest possible or it could be the smallest possible value or quantity. So let us try to apply considering extreme cases for this problem. No, let's say instead we have uh, 2 1 liters of water. One contains grape juice and the other half it's apple juice. So we take a tablespoon of grape juice and pour it to the apple juice. Then do the same from the new mixture of apple and grape juice. You take 1 tablespoon and transfer it to the grape juice. And so on, no? So you try to mix it that way and so on, no? So the question now uh, is there more grape juice in the apple juice of bottle, in the apple juice bottle, or more apple juice in the grape juice bottle? Kinsa mas dagan? Mas dagan ba grape juice sa apple juice or mas dagan ba apple juice sa grape juice? Okay. So, more likely if we try to solve it this way, so parang we will try to consider ano kaning um we try to consider solving it applying your calculus, no, using limits. Pero we will not try to do it that way. Okay. So why not we will try to consider uh the largest possible container that we can have. So we'll try to the largest possible container that we can have. Instead of transferring by 1 tablespoon of juice to the other, then to the other, then transfer and so on. So why not we are going to pour all of this in uh, one whole container. No? If we are going to pour this in one whole in container, kinsa may mas daghan class? Si apple juice or si grape juice? Take note that there is only half liter of apple juice and half liter of grape juice. So instead of doing 1 tablespoon to the other, why not we are going to pour it into the one large container. No? So kinsa na mas daghan ron? Si grape juice in apple juice or apple juice and grape juice? So if we try to look at it, no? So half a liter and half a liter so that we have 50-50, you know? So more likely, if we join them together, so more likely there will be, okay, so they are just the same. No, they are just the same. So there is as much apple juice in grape juice as there is grape juice in the apple juice. Yun. So they are just the same. No, so there is nothing more, there is nothing less. They are just all the same. Okay. Any questions before I proceed with the other six strategies? Any questions from the group? Yes, same. Okay, very good, Kenneth. No, they are just the same. Excuse me. Okay. Any questions before I would proceed? Okay. Okay. Sige. So I will just continue, no, on to the next strategy. The next strategy is making a drawing, no, making a drawing. So I guess if you have solved the last problem, if you have solved the last problem related to about sets, no, and some of you did apply the Venn diagram. Okay, a Venn diagram is an example of a making drawing strategy. No? So that is an example of a making drawing strategy. Okay, so let us try to apply making drawing strategy in solving this problem. No, let's say if one number is three times the other number and their sum is 28, what are the other? What are the two numbers? The common way of solving this one is that you apply algebra. No, okay, you did apply algebra. In my case, I will apply block models. No, so block models. Okay, so okay, I will represent these three blocks as my first number, and the one block is the second number. Since it is stated there that one number is three times the other number, no? So I have here, okay, just make sure that each block are of the same length, no? And the total, okay, these four blocks represents a total of 28. So I could say, so 4 units, 4 blocks represents 28. So therefore, one of this is 7. And the three of these blocks is 21. So therefore, I could say that the two numbers are 21 and 7. You know? 21 and 7. So let us try to check, no? Um, 3 times 7, it's 21. Tama, no? So we can say one number is 3 times the other number. And 21 plus 7 is equal to 28. So therefore, we could say that our answer is correct. Okay, so that's how making a drawing works. Another one is using intelligent guessing and testing. Intelligent guessing and testing is, in other terms, you call it as trial and error, no? So I will just do it guessing and testing, or some will call it guess and check. No? Guess and check. Okay, let us try to apply this strategy in solving this given problem. Mang Tomas owns goats and ducks. Counting heads, there are 39. Counting legs, there are 110. Okay, so how many goats and how many ducks Mang Tomas has? Okay, so this would be my solution. My first guess is, what if there would be 20 goats and 19 ducks? So that's a total of 39 heads. Now, so what about the legs? So 20 times 4, that would be 80. 19 times 2, is 38. So I have here 118 legs. So definitely this is not the correct answer. So my second guess is, what if I will have 15 goats and 24 ducks? So if we add that one, I have 39 heads, no? So how about the legs? So 15 times 4, I have 60 for the goats. 24 times 2, I have 48. For the ducks, I will add them. I will have 108. So again, this is not a correct answer since we are looking for a total of 110 legs. My last guess is 16 goats and 23 ducks. So 16 times 4, I have 64. For 23 ducks, I will have 46 legs. If I add them, I have 110. So therefore, uh, Mang Tomas owns 16 goats and 23 ducks. Okay, let us try to check, no? So 16 plus 23, so definitely we have 39 uh, heads. For the legs, 16 times 4, I have there 64. Then 23 times 2, I have there 46. If I would add them, a total of 110. So therefore, uh, I can say that this answer is correct. No? Yeah. So that's how guess and check works. Okay. So this is very efficient, no, if you have a multiple choice type of test, no, especially problem solving sa math, no. So you can definitely apply this method. No? Uh, Pag multiple choice ra gani ang exam, unya math problem, so you can always use this one. Ay lang mo pagsaba nga ang gamit mo ani. Okay, next strategy is the accounting all possibilities. Accounting all possibilities. So accounting all possibilities is just simply you are listing all the possibilities. No, you just simply list all the possible uh, occurrences. Okay, so just okay, yes, Kenneth, no. So let us say, for example, if you have a digit is inserted between two digits with a perfect square number to form another perfect square number. So find the three-digit squares to form in this way. So solution. So first now I will try to list all the possible two-digit perfect square numbers. And they are 16, 25, 36, 49, 64, 72, and 81. Okay. So the next way is that I will look to insert some digits between these between the digits of these two-digit numbers that would form a three-digit number perfect square. So it turns out, no, uh, only 225 is the possible answer by inserting 2 between 2 and 25. No? So it turns out that only the possible number is 225 by inserting 2 between 2 and 5. Okay, maybe you can look for, maybe I might be, there's something that I miss out here, no? So you may try this in your, uh, at home remotely. Maybe you can look for another perfect square, three-digit perfect square that is formed by this one, no? So, but my guess it's only 225 is possible, no? And for now, um, we'll just accept that the only answer is 225. Okay. Next strategy is organizing data. Okay, organizing data. Okay, organizing data class, it's really works if your problem is related to statistics, um, no, or also if your problem is like when you try to it involves of money, you know, or or it can involve you can also use organized data, applying organized data when it the problem involves patterns. Okay, organizing data involves these two strategies: either the use of list, and the use of tables. No, so organizing data are can be done into two possible ways: either the use of list and the use of tables. For this given problem, okay, for this given problem, the new jean store at 64 Fifth Avenue is giving prices to first 64 people who are in line when they open at 9:30 a.m. At 8:05 there were 8, at 8:10 there were 16, 8:15 24, and then so on. No, so at what time will there be in 64 people will be in line? Okay, so for this case, I just use table. No, so I did use table to organize the data for the said pattern. Okay, and this is the table, no? So at 8:05 we have 8, at 8:10 we have 16, 8:15 24, 8:20 32, 8:25 40, and so on. And by the time it reaches 64, it is at 8:40 a.m. So therefore, we can say uh, by 8:40 a.m. there will be 64 people in line. So the answer here is 8:40 a.m. Okay, 8:40. So that's how organizing data works, no? So you can use list or you can use tables. Okay, the next strategy is logical reasoning. Logical reasoning. Okay, patterns is also considered as logical reasoning, no? And we know uh, patterns are reasoning in terms of inductive approach, no? But here, when we talk about logical reasoning, we will talk about deductive approach, not deductive. So when you say deductive, from general to specific, no? From general to specific. So we will try to apply deductive reasoning in solving this given problem. So how can two fathers and two sons divide 900 peso bills evenly among them? Each must receive an equal number of 100 peso bills. Okay. Now, if we try to read this problem, it seems like there are four people involved. No? So if we divide 9 by 4, bungkig man, may sobra isa. No? May sobra isa. So it seems impossible. So it seems this problem is impossible to solve. But, no? But we can arrange it in this way. We can arrange it this way. So let us say na si grandfather, dayon na si father, dayon na isa ka anak. Ano? So in that way, pila ka book fathers? We have two, di ba? We have the father and the grandfather. How many sons do we have there? We have also two. We have the father and the son. Because si father is anak ni grandfather. No? So we can arrange it this way: a grandfather and father and a son. So therefore, each will receive three 100 peso bill each. Ano? So that means each would receive 300 pesos each. No? Yun. And that's it. No? That will be our answer. Okay. Let us okay. It seems it seems like the answer is odd. Okay, let us try to check. How many fathers do we have? We have the grandfather and the father, so that's two. How many sons do we have? So si grandfather, anak niya si father, so that's one. So si father, anak niya si son. So we have two sons. No? So, and each of them will receive evenly 300 peso bill. And that that's it. No? That's our answer. Okay. Maybe next week we will more of a logical reasoning, no? But siguro that's more of approving na nga part. No? That's more of approving part na. Um, we will have a separate meeting for that. Maybe on Tuesday we will talk about uh, logical reasoning and proving. No, next on not Tuesday, on Thursday. No, we will talk more about that one. Okay, the last strategy that we are going to uh, yes, very good, Nathan. No, grandfather, father, and son. Okay, well, that's very good. No, okay. So the last equation will be the last strategy is the use of equation, no? And this is the most common method of solving a problem, the use of equation. So let us try to solve this given problem using the use of equations. So the sum of two numbers is 177. If the second number is 3 less than the first number, then what are the numbers? So I will let here x be the first number and x minus 3 is the second number. So if we add them two, so x plus x minus 3, we have 177. Then just solve for x using uh, a linear equation in one variable. No, we have 2x minus 3 equals 177. So by applying removing negative 3 by adding positive 3 both sides. So we have 2x equals 180 divided by 2 on both sides. So x is equal to 90, then x minus 3 is 87. So we can say the two numbers are 90 and 87.